And we are recording. Welcome to the evening of Python coding. Today our speakers, multiple of those have either canceled or changed. So you get me. My name is Jacob Barhak. I've been running this meetup for a long time. Each month, on the third Tuesday, except from December, we show you some sort of library or Python tool. And today it will be DuckDB. So I'm going to share my screen and I'm going to show you DuckDB. Okay, hopefully you're seeing my screen now. Yeah, I see that you're seeing my screen. Okay, so what you see here is the website of DuckDB. Okay, it tells you things that DuckDB is a fast in-process database system, open source database system. Yes, you can look up on GitHub. It's a portable database system. Yes, it is very easy to install. It's analytical. You will see an example. And the in-process, I'm not sure what they call it in process, but perhaps we'll figure it out together later on. As opposed to not in process. I'm not sure what they meant here. Anyway, this is DuckDB. Let's go to the demo. You will find this GitHub site has a demo of DuckDB plus embeddings. It's on my GitHub account. Again, Jacob minus Barhak, DuckDB _ demo. You will find it there. And it's pure Python. This is what I like about DuckDB. So I don't know how much you know about use databases, but there are many types of databases, SQL databases, non-SQL databases, and today many of them require some sort of installation, and sometimes it's made easier by technologies such as Docker that just allows you to, import and install it and run it immediately on any machine you want. But there are sometimes you don't want anything external. No, maybe this is what they call in process, meaning something that you don't need to go out and connect to a database outside externally. You can just bring it into Python very easily. So DuckDB is one of them. For people who are familiar with MySQL, it comes with Python. It's a SQL database. DuckDB is also a SQL database. MySQL is a very basic database. It has it gives you many things, but it has some limitations as well. DuckDB is a little bit more advanced. It gives you things that MySQL and many other even more known databases don't give you. So one of those things, actually, let's go to DuckDB and let's go on GitHub. It has 3,000 stars. Okay. One of the things I like about it is it has MIT license, meaning you have no problems with GPL and stuff like this. For people who don't know, GPL is general public license. It's a license kind of that infects other software rather than lets it use. It's an open source license, but the idea is that make everything kind of communistic, meaning, oh, if you use me, then yes, you must use my rules, and my rules is you give everything away for free. Something like this. I'm kind of exaggerating. So this is not DuckDB. DuckDB is MIT license, which is called permissive, meaning you allow people to use it freely, but you can, if you are a business and you want to use a database, you rather not use anything with the words GPL on it. You rather use something that has a license which is permissive, that allows you to do things with the code. So MIT is one of the most permissive licenses there are, and DuckDB is an MIT license. So this is one of the reasons I like it. Another reason I like DuckDB is because you just import it into Python. You don't need to install Dockers and configure all sorts of things. No, you just import it into Python. Let me show you the code that I've written. In the code that I've written, you just install it. Yes, of course you have to install it. So I used either UV and pip install. For people who aren't familiar with this, pip and UV are package managers that allow to bring Python packages that are outside. So if I need an SQL database, I usually use SQLite, which comes with Python, that I don't even need to pip install anything, but it's quite common to install packages in Python. So if I need something that SQLite cannot do, then I install DuckDB. This is my second go-to if I need anything, and it's a good database. And in this situation, this is what I've done, and I'll just show you the text. So here, the first thing you do in any code is you import DuckDB. After you installed it, using pip or UV, you just import DuckDB. And now you can use it immediately. No need to special setups, no need to, configure things, Docker things, remote servers. No, all of this is gone. You immediately can start using it very easily. So this is one of the advantages of DuckDB. And there is another advantage of DuckDB, that it is a modern database that supports things like semantic search off the shelf internally, almost off the shelf. I'll explain. You still need some other tools, but it allows you to store vectors. For people who don't know, today in machine learning, a lot, AI and machine learning, all of those things basically transform data such as text, images, or whatever, they transform to vectors. And then you can do things with vectors such as similarity search. So with words, it's like the word queen may be close to king because they're both royalty. But they may be unclose to pauper, for example, or any other word that is not royalty related, I don't know. So, or pencil, for example. So those are things that the vectors should be close enough to each other when you transform them into vector space. And there are many, many tricks around it that are made in machine learning or AI that do this. One of the basic ideas today is to do something called embeddings. In embeddings, you give AI some sort of object, typically text or image or whatever, and it calculates a vector for it that is close enough. This vector is basically, you can put in a database. And later, if you want to find things that are similar to this, you just embed whatever your query, and then you just see whether there are any vectors in space that are close to each other. It's called cosine similarity. It's just what is the angle between the two vectors. Okay, and the cosine of angles of the same vector is 1. So their similarity is 1. But cosine similarity means the farther the vector it is, then your similarity will be lower. And therefore you'll know this is not the same thing. So one thing that I'm doing here is I have a code called prepare.py. What it will do is I'm going to create a database called embedding.db. First of all, of course, you need to connect to the database always. So basically duckdb.connect, and that's it, and the file. This is how you connect it. Once you're connected, you can run queries. The first query we'll do is we are in the file called prepare.py, which we will create a table. We ask it create a table if it's not already there. It has a line number, file name, author, title, content, embedding, and then a primary key. Yeah, we can change those things, but basically a primary key is like the index of the table. I'm added this primary key so there won't be any duplicates, but you can do whatever you want in your table. Later on, I'm giving it the file. Let me show you the text that I have. I have 3 texts here. A text by Jules Verne, Lewis Carroll, and Mark Twain. I downloaded them from the Gutenberg project. Those texts have no copyright anymore. It expired because after 80 plus years, then or after a specific date, then those texts become public domain. So we can use them, and I use them here. And no fear about copyright or anything. So I'm taking those texts and I'm putting it, and I want to create a small program that will parse them. line by line, and each line in the text, let me show you some of those texts. Okay, sorry, not this one. Not this one. Here we go. So here's Jules Verne. Okay, so this is for people who see it's Phineas Fogg in 80 around the world in 80 days. So Gutenberg project give me everything, chapters and whatever, but also the text itself. Lewis Carroll, the same thing. Alice in Wonderland. Mark Twain, Huckleberry Finn. Okay, there are many chapters and so on and so forth, and of course, it's an ebook. This the text for an ebook. And actually, in Huckleberry Finn, I actually made a mistake. So I just downloaded something which is incorrect, but it's not a big deal. There's credits. Okay, sorry, I did correctly. So this is about the recording. Okay, it's not a book, but still, it's something. So I downloaded the wrong thing, but it doesn't matter. But you will see why. What I'm trying to do is I'm trying to look at the text here. And I asked, now I want AI to come and tell me, after I plugged in all the text in the database, and I asked some questions, and I want to know what text belongs to a question that I'm asking. I'm going to ask for a semantic search, not exact search of the exact same letters, but something that is close by. Actually, it can be the same letters, but you can actually do something like mistype or something, and it will still try to do the best to actually find the text. Or something in the style of Jules Verne, or something in the style of Mark Twain, or actually Mark Twain, we don't have data, so not that much, but Lewis Carroll, for example. You can try and see whether some words fit more this or more that. It will tell you what similarity it is to the text. And you can ask several of those questions. So this is what I'm trying to do. Let's see how we do it. So first of all, we pass the file. We pass the file to add information into the database, and in the database we'll have, you see, embeddings, float, and you see this brackets. This means it's a vector of floats. This means it's a vector. Embedding is a vector. How do I extract those embeddings? There's another library called sentence transformers that allows me to do this. We'll later on see how it's being used. So actually, I'm going to switch now to the development environment so you can actually see this. Here's the text. You don't need to read me for now. Hopefully it's good enough for you. Is it big enough for you to see? Well, I hope it's big enough. No one's telling me no. Oh, okay. You can read the text. Perfect. So I'm going to go show you this file. This is the preparation file. And what I'm going to do now is I'm going to load the embedding model. You see the model is called sentence transformers. This is the name of the model I'm going to use. What's going to happen is that this model will be brought in from Hugging Face and will be named after a model. We'll later use it. You will see later. Later on, I'll connect to the database. I create the table. We already showed the creation of the table. The text, it checks that the directory does exist with all the text. And then for each file name in files is all the files that that with the text extension in the text directory. It will, I don't know if there are beginners here, but this is something you can do in Python. It's called list comprehension, where we actually say for each F in here, which is the directory listed, if it ends with text, if file ends with text, then you will use the file. So this is the files. These are all the files we're going to use. So for each file name in files, you open up to the text directory. You, of course, join the path to go to the correct, the path, the full path is the text deal and the file name. You join the paths and you process the file name. Then you extract, there's something called parse file. It's a function. This is here. The parse file will go and look for the author, and the title of the book. The author and the title in all of those examples are, where was it? It looks like this. It starts with title, starts with author. So basically, we're looking for those. So we're gonna open the files, and for each line, and you keep the line number to see what line it came. If it starts with title, then we found the title. If it starts with author, we find the author. Then, if start of the project Gutenberg book, if you find this thing, this means you have started parsing. You end parsing when you get to the end of this, and for each parsed line, you add the line number and the strip line, meaning the text in that line. That's it. This text goes later on, after you parsed it. We'll go back. After we processed it, all of those, we have the line processed, you have the line numbers, you have the text, and you have the embeddings. And the embeddings, you just ask model. You remember we took some model from Hugging Face. We encode all of those texts, which is basically a list of lines. Each line on the list becomes its own, goes here and becomes a vector. What you get out of this is a bunch of vectors. Now we add those vectors and we insert it into the database. Actually, we just collect it into data to insert, and it becomes a tuple like this. So we add the line number, the file name, the author, the title, the text, and the embedding. Okay? All of those are going to be added to the information. Each one of those is a vector of its own. Okay? And this is how the insert happens. You add line number, file, author, title, contents, embeddings, and you call it from this data to insert. Notice you're using simple SQL as used for anything, many things, and the connection execute many will execute. There are many elements here in this data to insert. It's kind of like a vector of vectors. Each one of those is a vector. Actually, the embeddings is a vector of that. Embeddings is a vector of vectors, actually, because what you're entering in the embedding is a vector, and it will know how to do this. This is unique to DuckDB. Actually, not unique to DuckDB. It's unique to modern databases that support embeddings. Older databases do not sometimes. So if you want to use AI, you probably want to go with something like more modern, like DuckDB. Okay. So you have eventually, you count how many lines were inserted. If you have errors because you inserted the same line twice, then it will skip it. And then eventually it will report how many files were processed and so on and so on. So let's do this. I have an embeddings.db file. Let's rename it. It will be the same if I do it, but old. Okay. Let's run. This is how you run the prepare. We're going to run it now, and you'll see how it works. We're going to create a new embeddings for me. So here's the command I write. UV is because I'm using the UV package manager. Instead of writing many things, I'm just saying UV run. This means it's setting up the environment and running it from within the environment. with all the correct libraries. As opposed to other techniques, you had to set up things before. In UV, no, you just tell it immediately, no, I want you to run it from this directory, and it knows to look for specific files in this directory to set up the environment. Okay, while we're running it, the first thing you'll see, it will start bringing in an embedding model. Ignore the warning for now. And now for each one of those files, it tell you how many lines it's inserted, how many lines it's skipped, and so on and so forth. It may take a while. The reason it takes a while is because embedding is kind of a heavy operation. You're actually running a small model on it. Typically, it's an LLM. I believe this is a tiny LLM, the one that I'm using. We'll have to look at it later, but it can be not necessarily an LLM, but LLM, large language model. It can be something else, some sort of model. I'm not supposed to, since it's running on CPU and not on GPU, it's not like a really sophisticated LLM, but it's not ChatGPT or anything. But you can embed with ChatGPT, you have embedding models there as well. Those are typically paid. This model is small enough to fit in my machine, and it does this. And as you can see, it's adding lines. Most of the time, it takes because it's embedding things, not because it's writing to the database. The insert to the database is really quick. It's like it's generating the vectors is the thing that takes a lot of time, but not always. I've seen examples where sometimes the database becomes the bottleneck. Anyone has questions so far while we're waiting for the machine to finish?
Me.
Yeah, Elliot, go ahead.
A question. You were, it's my first time here, so I'm a little bit lost. I'm a little bit, Um, you were, do you were explain your project, or because I didn't get really well.
I'm just showing a demo of a library called DuckDB. Actually, it's a database called DuckDB, which has a live Python library. So I'm just
But that
showing how
is
I use things and why am I using them for. But
right, but that is like a new demo language or something like
well,
for coding.
DuckDB is relatively
Yeah.
new compared to other databases. It's more a modern databases, I explained before. There are older databases that don't have embeddings in them, or don't have the ability to store vectors. This one has. And if you want to use AI, you might want your database to be able to store vectors and stuff like this. As you can see, it's finished all the processing. It added 7,000 lines into the database. I have an embeddings DB file. Now, let me show you why, because I see someone who already asked why. So there's a second thing that I'm going to do. I'm going to now, after I created the database from those texts, I'm going to ask questions that are searches on this database to find out things. Like I wanted to extract the line that's closest to what I can think about. And we can explore what it can do. What it's going to do is basically take my questions, my query, convert it into a vector, and then find the vector similarity. And it will do it using DuckDB language. In DuckDB, it's very easy to do this. Here, select the title, the author, the line number, the file name, the context, and then list cosine similarity, embedding, and your question, and it will give you the similarity value. And then it will order it by similarity descending, and it will limit only several records. This is done very efficiently if you have a correct database that can do it, and DuckDB can do this efficiently. That's the nice thing. It can process it efficiently. I won't go into details of how it's done, but DuckDB does this and it supports it to some degree. There are many databases in the all compete about how being able to do this better or quicker. Now, let's go over the code before we run it. So first we connect to the database. Then we load the sentence transformer, the same model we had before. So it will be stay in memory. And then while true, I'm going to enter a query. And it's going to continue until asking for a query until I stop asking questions. And each time it will run the query and will display the output of what the query, which will be the title, the author, the file name, the line number, and the content, meaning the sentence it found, and the similarity. How similar what was I asked according to the model to what it found in the database. Now notice, what I'm going to ask is sometimes sentences that are not the same, but very close. So similarity will never be one, but it will be the closest. They'll give me the closest. So here, let me write the question. So here, the usage is fine. And in the find command, we are allowed to ask how many examples, how many sentences to bring back. Because sometimes the first sentence is not the most similar one to the one we want to find. So we're going to run this command. So it will load the model first. Model is there, and then it asks us for a query. So let's say we're looking for Mark Twain. So we want to see something related to Mark Twain. So let's say Huckleberry Finn, but we can't spell Huckleberry, so let's just say Finn. And it tells me, here are the sources for the answers. The Adventures of Huckleberry Finn by Mark Twain. Okay? This is what it found, and the similarity here was 0.3, because I didn't say the Adventures of Huckleberry Finn, I just said Finn. So we find out that Finn is closest here. But notice, it also tells me Around the World in 80 Days by Jules Verne, because the word him appears there in one line, and him is almost like Finn. And here it's just Flanagan, and Flanagan is kind of by Finn, but it also shows me something else. But the first answer is correct. Let's ask something else. Let's talk about rabbits. So it tells me, oh, in rabbit, sorry. So perhaps I misspelled it. It was working nicely before. Yeah, something went wrong before. I wrote down rabbit. So it finds me Alice Adventures in Wonderland by Lewis Carroll. The rabbit sends a little bill, and the similarity is 0.65 because rabbit does appear here. Text the rabbit jumping up in great hurry, and then similarity this. Then Alice Adventures in Wonderland. So when I say about the rabbit, apparently there aren't any rabbits Around the World in 80 Days. But let's try something that appears in Around the World in 80 Days. There is a guy there, his name is Passepartout. He's French. He's like the assistant of Phineas Fogg. So let's try Passepartout. But I don't know how to spell Passepartout correctly. I just spelled Passepartout the way I think it is. And it tells me, oh, Around the World in 80 Days, sorry. Here, Passepartout, 3 matches. So it tells me the lowest match is Around the World in 80 Days, a word called ruffian. No? And then it found out the second answer. It says Around the World in 80 Days, you're doing the Texas console. For some reason, it thinks console is like Passepartout. I don't know, maybe because Passepartout is like passport and then console somehow relates it. I have no idea. It's a language model. It has its own connotation. But then again, Parlez-vous said Passepartout. Here it is. In the third answer, it found the correct way to spell Passepartout and find, yeah, this is similar enough. Is this what I wanted? In this case, yes. Anyone has other ideas for queries we can ask from those three things? Like here, let's say something Queen. Queen appears probably in more than one of those, but here, Alice Adventures, Squirrel of Heart, Alice Adventures Around Word, but also Around the World in 80 Days, Jules Verne. I arrest you in the Queen's name. So Queen appears in all of those. But so anyone has any questions or anything that you want to check the system, and you can find like a sentence that appears there.
I tried an interesting one. I put in the word ironic.
Ironic?
Yeah.
Okay. Why ironic? Let's see where ironic appears. Jules Verne, 80 Days, Angularly, I don't know the word. Not wrong, ironic. It's Around the World in 80 Days, and that's for jerk. In similarity, 80 Days. Similarities are still, but it can be something that is not like necessarily.
Well, and then I put in irony and compared the response to both of them, and I thought that was
irony. You spell it with a Y at the end, like this.
Yeah, IRONY.
Around the World in 80 Days, betrayed by his emotions. You see irony and emotions, betrayed perhaps. Articles and also partially the logical periods of questions. Around the World, and justice apparently is a word that relates to irony. I have no idea, but the language model thinks like that. Okay, let's say something else. Tweedledee and Tweedledum had a big fall, and all the king's soldiers and all the king's men. Okay, I hope I spelled it right. Were in custody of the soldiers. All the out ornament with hearts came up with guests, mostly kings. And then the king and the read from the book. So apparently it's all from Alice in Wonderland. It figured it out, but it didn't say Tweedledee or Tweedledum. So all the king's soldiers and all the king went. It's actually not Tweedledee, it's Humpty Dumpty. Yeah. Humpty Dumpty. No, Humpty Dumpty thinks some hump. It's like Humpty or hump. Humpty Dumpty. I think no, it cannot find Humpty Dumpty back together again. Perhaps it can find it. Yeah, it cannot find it. It thinks it's Jules Verne, apparently. But matches are. Anyway, so, but this is a small language model. I didn't put any effort in it. It's just to show you possibilities of what's possible. Like, I missed some of those texts that appear, some of the messages. Okay.
Doesn't the caterpillar try and explain to Alice what the name of the song is called? And he says the song is this, but the name of the song is called that, something? Or is that in the Looking Glass book?
Let's see. Name of the song.
Yeah, okay.
Alice in Wonderland. Faintly intense melody. Sit down, all of them, and listen to me. This is Leo's Carol, actually. No, this is actually, no, this is Jules Verne, the first one. Painful intense melody. Second one is Around the World. A rap, this moment sounded the door of a cozy apartment where. But notice that those things are related to singing or to noise or to anything. So it makes sense to some degree that it found it. Now, look.
That's impressive.
Yeah. It's a toy. What I gave you is a toy. Now, someone was asking how it can be used. So those are used in databases for many things, like finding similarity of images. Like, show me an image and how similar this to this. It's not always correct, but it's close to, you can see like things that are, you can understand why it thinks so every once in a while. But I showed it about in text. Someone is either asking something or something appeared on
Yes.
screen. Yeah, okay. What
You
do they want?
mentioned sentence transformer and list cosine similarity. Are those part of DuckDB, or those are things you're using to explain how DuckDB works?
Okay, it has nothing to, okay, DuckDB has, okay, there are several things here.
Okay, please explain.
Okay. The transformer, the model, embeds the text, meaning it converts it into a vector. A vector in space, n-dimensional vector, and usually it's like 2000 size vector, or 2048, or 1024. Those are how big the vectors are. Okay, so the model converts it into a vector. Okay?
The sentence transformer thing.
Yeah, the sentence transformer converts things into a vector.
Okay.
This is what it does. Now we store the vectors in the database, and we need to ask a question about how similar they are to something else that we're going to ask them, correct?
Mm-hmm.
This is where cosine similarity comes in, and this is what DuckDB has it embedded in its own stuff. So here, let's show you the find again. This is the select statement in DuckDB. And it has something called list cosine similarity.
Which is in DuckDB itself, right?
Bingo. Notice it's a function.
Okay.
It's a function that encloses something called embedding. Embedding is the field where we store the vector. Okay? And then the question mark is our own vector that we're going to plug in inside. So it's going to find the cosine similarity between those two vectors. Basically, it's going to calculate the cosine of the angle between the two vectors. If it's the cosine, it's basically the dot product, if people know what it means. Okay, if you do the dot product, you get that. Okay, once you have the angle, then if it's complete exact thing, it will be 1. Okay, so here, for example, let's give an example. Around the world database, I'm going to take this line and I'm going to add it in the query. Okay, I'm putting the exact same line in the query. You see, I'm going to enter it. Then it shows me again similarities, but notice the similarity is 1 because I put in the exact same word.
Because that's a function of DuckDB. Is the vector a data type within DuckDB?
That's the thing. Yes, in DuckDB you can store vectors. This is why I said it's a modern database. In older databases, you could not store vectors. You could store floats, numbers, text. You could not store vectors, or if you could store them, you could not do the similarity as part of the database engine. In DuckDB, you can, and it will look for them, and it will tell me list cosine similarity, and it will order by similarity descender and limit to 3, and it can do it efficiently. Okay. Now, how efficient it depends on the database engine. This is where I lose myself because I don't know that much. I just know that it can do this what I just showed you. One more thing, it cannot, like some other databases have very specific ways of actually have different ways of saying the similarity. This thing has not been standardized in SQL as far as I know in all databases. Each database has its own technique on how to find those similar things. It has its own language. Maybe some of them are the same. Maybe they're standardizing it now. Maybe it's already standardized. I just don't know about it. Maybe the new SQL standard will have something like this. I don't know at this point. But I know that this is something that appeared in the last several years, and databases started appearing, and DuckDB is one of them. And this is why I like it. It's easy to use. You don't have to write, if you write code, you just need this, then immediately you just install DuckDB, just any other library and start using it. You don't have to put it on a different machine. You don't need a Docker thing to lift it up. You don't need administrator. You don't need anything. You just push, you're just working with it. And this is why I like DuckDB. Yes, you have another question. Ava? You can ask a question, please.
Question.
I,
Can you hear me?
Yeah. Go ahead.
Where would I find the DuckDB at? Where would I find it at if I wanted to download it?
Oh, so it's here. DuckDB is on several places, but whenever you write down the command pip install or uv pip install, it will bring it from wherever it is and will bring it to your machine. That's it. This is, let me show you. In this command, actually, it's have, when you see import DuckDB, it's already on your machine and you're just using it. It's saying, I'm using this library, just like using in Python many libraries. You see, I'm using argparse, I'm using sys, I'm using sys transformers. Those are things brought into my machine. Okay? Where I actually bring it is
in the
when
Visual
I actually,
Studio app?
whoa, let me finish explanation. When I actually bring it is here with those commands. And you see there's a file called requirements.txt. It has all of the things that I need to bring in from the outside world. Typically, those sit in a place called PyPy, which is, I'll show you. Actually, now this is just, yeah, here, pypy.org. Okay? So this is the packet manager. There are like almost 700,000 something projects with 8 million releases. This is how many files are there. So people who developed it uploaded it to PyPy. Here is where they develop it. DuckDB is actually on GitHub. This is the DuckDB GitHub. You can actually see, since it's open source, you can actually see how they wrote the code for that. So everything's kind of open and people can figure out, yes, we want to use this because it's good, it's safe. You can see how many issues are there here. These are things that people complain about, and you can see that things are closed. You can see that there are 500 issues open, but 6,000 closed. This means the team is working well on actually making the DuckDB a good database. You can actually see also that this database has, where is the number of stars? Here we go. 36,000 stars. This means that at least 36,000 people were very happy with it. This is a huge number. There are more, there are less, but this means that this is a good project. Okay? Did I answer your question where it is and how do I bring it?
Yes, thank you.
Okay. Elliot, you want to say something?
A question. Sorry. PyP is the same thing to Python language?
So Python is a repository where all the Python packages are stored. There are other repositories like Conda, and UV probably has a mirror of something as well. I don't know how UV operates exactly, but I assume as well. Because I know it can operate with PyPy because it says pip. We say pip installed, and the pip is what brings things from PyPy. This is PyPy. You can actually go and look for any type of project. So here, what kind of, here, something relating to language. And it tells you, oh, there's something called language. There's something called extra language. There's something called theta or whatever. So those are all packages that people have done. And there's information about, you can later on say, oh, I want only certain licenses. I want certain development status, frameworks, all sorts of things you can search for. But this is what PyPy is. It's a huge place where everyone who wrote code put stuff there.
Oh, okay. Thank you.
Any other questions?
Yeah, I had a question. The model that's grabbed from Hugging Face,
Yeah.
is that invoked from within your Python program, or how does that work?
Yes.
What
Yes.
makes
So
it
there are some things here that are hidden because the package does this for us. So let's see. Where is the? Here we go. So let's go back and see what happens. Like not the embeddings. No. So the package is called Sentence Transformers. You can find it in PyPy. It's affiliated with something on Hugging Face. As far as sure. Actually, let's see who did this. Let's go to PyPy. And we'll just add Sentence Transformer. Second, you're going to grab this. I'm going to go here. I'm going to paste it. Here's the package. And here in Sentence Transformers, it tells you exactly embeddings, retrieval, and re-ranking. And it supports 15,000 50,000 pre-trained sentence transformers models. You can choose for 15,000. Now, where does it take the sentence transformers? I suspect from Hugging Face. Hugging Face is mostly, most of the things exist there. I'm looking to see if there's this Hugging Face signature, like here. This is the guy who wrote it. Actually, let's go see where the homepage is. It's sbird.net. This is what it is, Sentence Transformers. That's library. I'm trying to answer your question as best I can, but some of the things I don't even know. It has to, let's see the repository. Yes, it's from Hugging Face. You see, the company called Hugging Face, they created Sentence Transformers. So basically, it will grab the model from Hugging Face. And you can replace it with about 15,000 different ones and see which one's better for you.
Okay.
Okay?
Yeah.
Any other questions, or can I wrap this presentation? No more questions? Questions going once? Questions going twice?
I think somebody put in the chat. Santir say, so what? So you download this from GitHub or PP or PyPy?
I'm gonna let Santiago know.
Okay, so it seems you've been answered. So
I got it, Jacob. I'll let him know.
Okay. So GitHub is the place where people collaborate in writing software. When they work on GitHub finishes, it goes to PyPy. Typically, it can go to other places. It doesn't have to go to PyPy. But typically, people who develop Python programs eventually go to PyPy. By the way, PyPy is only Python. There are many other languages that people develop stuff on GitHub. GitHub is a place where people collaborate on writing software, and you can view the software and the code itself. PyPy is where actually Python installs stuff from. Okay? Okay. Questions going once? Questions going twice? Questions going 3 times? No more questions? Okay. Then I'm going to thank myself for giving this talk. Someone, Derek, thank you very much for the good, for the applause. Robin, thank you. Don't go away. I'm gonna just finish the recording, and we're gonna stick around here. Don't go away.